Hello friends, this is the third video in Arduino video series. In this video, we'll learn the sensors, actuators and data acquisition system. In first two videos, I have explained the Arduino, what is Arduino, and the programming concept of the Arduino, how to do programming in Arduino. So do watch that video. The link of that video I have mentioned in the description box of this video. So let us learn what is sensors, actuators and data acquisition system. So sensors acquire any physical parameters and convert it into suitable signals for processing. So very easy, the sensors physical parameter. So these physical parameters may be the optical parameter, electrical parameter or mechanical, or there may be a thermal parameter, magnetic, biological or acoustical parameters. So any of these physical parameters, the sensors can measure these parameters, and these sensors provide the usable output in response to any change in the physical parameters. So input signal to the sensor, that may be any physical parameter out of these, and there is a system that converts that parameters into the useful output or measurable output it can give. So this is sensors, simple definition of these sensors. So for example, there are number of sensors available to sense various parameters. Out of this, I have some of the examples I have taken here. So you may be aware about these sensors. So temperature sensor, it is very often used sensor, LM35 3-pin IC, which senses the temperature. So these sensors, 3-pin sensor, it is having the input voltage is from 3 volt to 5.5 volt, and the ground pin is there. So let us see that pointer. Okay, so that the VCC supply pin, the ground pin and the analog output. So this output, the analog signals, that will be a 10 millivolt per degree Celsius. So this gives output with a change in the output voltage. So simply whenever there is a change in the temperature, it changes the analog output signals which are in millivolt, and that can be directly connected to analog pin of the Arduino, and which is having actually inbuilt analog to digital. So it can directly measure from this pin number. So we can measure temperature with the help of these sensors. So here physical quantity is the temperature and the output which gives the change in the voltage signal. So second is a LDR, which is light dependent resistor. The name indicates it is a resistor whose value depends on the light. So any change in the intensity of light, it change in the output resistor. So with the help of that output resistor signal, we can use it for the street lighting control. Another one is a load cell. This measure the load that applied on this cell. So it is often useful in the weight measurement, where the load is given to this and it gives reading after modifying the signals or signal conditioning. It gives reading in terms of kg or gram, whatever we want. So this works on the Wheatstone bridge principle, where the change in the resistance takes place at the time of loading the system. So it gives the output change in the resistance. Another sensor is an audio sensor, acoustical sensor, which senses the audio and again gives the output in terms of electrical parameter. So with the help of these audio sensors, we can get the audio sense with the help of this operational amplifier and the sensitivity control potentiometer. Another one is ultrasonic sensor. This senses the distance. This is one transmitter, one receiver, which senses the distance, which is often used in case of the distance measurement in various applications. This is infrared sensors, IR sensor we can also call, which senses the any obstructions against this sensor. So it will sense that obstructions and give the output signal to the signal conditioning unit. One is a transmitter again here, another one is receiver. We can again change the sensitivity we can change from this potentiometer. Now actuators. Now simply actuators, it is a mechanism that converts some type of energy in order to do some useful work. So very simple. Most common actuators used are motors, solenoids, pneumatic or hydraulic. These are the most widely used actuators. We all of know the motor, which converts electrical energy into mechanical energy or any physical motion. So with the help of that motor as an actuator, we can get the output done. So these are the example. DC motor, we know with the help of this DC motor we can do many of these functions. So any rotational motion or linear motion with the help of the gearing system, it can be done with the help of this DC motor. Another type of motor is a servo motor. Servo motor is often used in precise positioning system where we want to move the any system with some rotational angle, like a robotic arm. We want to move robotic arm in 90-degree. So with the help of this servo motor, we can achieve that applications. Another one is a stepper motor. That stepper motor works in a steps. So this is often applicable in various automation or robotics. Again, some general applications are scanner, printers, also wristwatch or the watches, various watches it can be used. Another actuator we can see solenoid switch, as I have given in the previous slide. Solenoid switch, it is a push-pull type solenoid switch, often useful in various starters in the system. Next we'll see the data acquisition system. That means how to store the data in the system. So with the help of this system, sensors, various sensors, we can sense the physical quantity. So physical system, that may be any like temperature, electrical quantity, maybe the optical, acoustical, whatever the physical parameter we can measure from these various sensors. These sensors output is a noisy electrical signal. That means what is the sensor senses? It is not a measurable, or actually it is not a useful signals. So it has to become a useful with the help of the signal condition or measurable signal, which can be used with the help of the signal condition. This may be operational amplifiers, various amplifier circuit. Here it can be used, and that signal becomes the measurable signal. Now if the signals are the analog signals, then with the help of this analog to digital converter, we can convert it, and that digital signals are provided to the computer. If the signals are digital signals, after output of the signal conditioning unit, then directly it is given to computers. So the computer will store the data output of the system. So this is what the data acquisition system, how the processes are done in the data acquisition system. With the help of sensor, we can sense the quantity. With signal conditioning unit, we can condition that signal, measurable condition that signal, and with the help of this converter, we can get the digital signal, which will be stored in the computer. In the Arduino system also, data acquisition system, we can store that parameters, any physical parameters, we can store with the help of this data acquisition system. So for example, if we take the temperature, which is a physical quantity, so if you want to measure the temperature and store data in the computer system, the temperature, which will be a physical parameter, then sensors will be a LM35 or any other temperature sensor we can say, which will be a sensor. Then signal conditioning unit will condition that signal in measurable parameter, ADC. If we consider the Arduino, then ADC is inbuilt in the system, and after this ADC, which will be stored in the memory of this computer system. So this is how the data acquisition system, the blocks, various blocks in this system. So in this video, Okay, in this video only up to this point we'll see. So thank you for watching this video. Thank you.